Algebra I 10.5a, we're going to add unlike denominators using a pattern. And I'm sorry, I have a really bad cold, so I hope my voice isn't too bothersome. We can add rational expressions with unlike denominators by using a pattern that works for adding fractions. Now, if you remember from grade school, when we added unlike denominators, we stacked them. So if we wanted to add 2/3 and 3/5, we found a common denominator for them, didn't we? The 3 and the 5 can both meet at 15. So 3 needs to be multiplied by 5 to get to the 15, so we multiply the numerator by 5 and we get 10/15. And for the 5 to get to the 15, it needs to be multiplied by 3. So we multiply its numerator by 3. It gets jealous. So it wants to be multiplied by the same thing, see? And that becomes 9/15. Now we can add 10 and 9 and get 19/15. Well, when we're doing unlike denominators, we can also use a pattern. So we got 2/3 and 3/5, right? So here's our 2/3 and here's our 3/5. Basically what we're doing is we're taking this 2/3 and we're multiplying it by 5/5. This one's denominator, see, as a 1. Then we're taking this 3/5 and we're multiplying it by this one's denominator as a 1, 3/3, see? 2 times 5 is 10/15, and then we're going to add that because it's an addition problem for rational expressions, and we're going to get 3 times 3 is 9/15. Now, we don't need to write this 3 times 5 and this 5 times 3. We can do it just as 1 3 times 5, okay? We can do it as just 1 over, under the numerator, okay? We're still going to end up with 10 plus 9/15. We're still going to end up with 19/15, see? So we got the same answer, we just did it a little bit different way. So this was the pattern we used. You should write this in your notes. If you've got P is the numerator and Q is the denominator, and we're going to add it to R over S, what you do is you take P times S and you add it to R times Q, because remember when they're next to each other like this, it means multiply. And the whole thing is over this Q times S denominator. See, they're together, so that means multiply. See? So even though we're adding, what we're going to do is we're going to multiply these and add it to these multiplied together over these. Okay? I'll show you some more. So here's our pattern. Okay, I wrote up here to help us. And if we've got 3 over x squared and we're adding it to 6 over x, we do 3x. Okay, that's multiplied together right there. And we're going to add it to 6x squared, see? And the whole thing is over x squared times x, see? That's using our pattern. Now we can factor to find common factors. 3x plus 6x squared can factor out as 3x times 1 plus 2x. And the whole thing is going to be over x squared times x, see? If you don't remember how to factor, there's a link in this description to take you back to all the factoring videos. If you don't remember how to do it, because I know that was from Chapter 6 and we're now in Chapter 10. It was a while ago, so I can understand if you've forgotten. And just go back and review it for 15 minutes and it'll really, really help you. All right? Because if you don't remember how, you're going to be completely lost. All right. So now the whole thing is over this x squared times x, and when we simplify it, this is what we've got. This x and this x cancel each other out, and we're just left with 3 times 1 plus 2x over x squared, see? All right, using the pattern, we rewrite using the pattern. So here it is rewritten using the pattern. We got 3 times x minus 1, right there, plus 5 times x minus 1. The whole thing is over x plus 1 times x minus 1, see? So now we combine like we do our multiplication, our distributive property, see? We get 3x, see, minus 3, and we get 5x plus 5. See that when we do our multiplication, our distributive property? Now we can combine like terms. We got a 3x and a 5x. That makes 8x. And negative 3 plus 5 makes positive 2. Now we can factor to find common factors. So you may think that this is already factored, but it's not. We needed to do the distributive property to this. We needed to combine the like terms of 3x and 5x and the negative 3 and the 5 to get here. Now we can factor to find common factors. And 8x plus 2 factors out as 2 times 4x plus 1. See? 8x plus 2. See? Same thing as that numerator. And the whole thing is over this denominator. And now there's no common factor, so we're finished. We've simplified it. All right? So remember, a fraction, a rational expression, is simplified if its numerator and denominator have a greatest common factor of 1. Then you know you're done. All right, here's another one. All right, we're going to rewrite it using the pattern. We've got 2 over a plus 2 and 3 over 2a. We're going to do 2 times 2a, that's right there, plus 3 times a plus 2, right there. See? This becomes 4a plus 3a plus 6. See that? When we do our distributive property here. All right. So now we've got 4a plus 3a plus 6, and we can combine the pink-like terms. The 4a and the 3a become a 7a. We add our 6, and the whole thing is over a plus 2 times 2a, isn't it? All we did was put the 2a in front. All right. See that? So basically what we're doing, just to reiterate, is if this is our fraction and this is our fraction, we're crisscrossing like this. We're doing p times s plus r times q over qs. See that? Here you go. Now we can also use least common multiples, and we're going to do that in 10.5c. But before we do that, our next video is 10.5b. We're going to talk about how to subtract rational expressions that have unlike denominators. If you want to go back to any of the previous videos or to that factoring playlist, and I'll even have some separate factoring videos to help you out, I really advise you doing that if you've forgotten. They're all in this description, and you'll be able to just click on the link and watch it, okay? All right, so Lola's going crazy as I'm trying to make this video. I've been trying to step over her. So, all right. I hope this was helpful, and I'll see you next video, and hopefully I'll get over this cold real soon. All right. Bye.